four panelists with us right now. The fifth one will join us in just a bit. But we do have Bruce Chamberlain from UC Berkeley, Josh Morejohn from Stanford, and Stephen Porder from Brown University.
UC Davis, actually, but
oh, I'm so
Fahmida's from Stanford.
She is from UC Davis. Sorry about that. Right. Oh, fantastic. And our fourth panelist this morning is Fahmida Bangert from Stanford. Welcome, Fahmida.
Hi, I finally managed to get in.
Yeah, we're so glad you're here. So the way we're going to run our session today is I'm going to let each of you introduce yourselves for a short little bit, and then we can start with some questions that we have provided for this conversation, but also the Q&A from our audience members. So do you guys want to go from west to east, starting with Bruce Chamberlain, perhaps?
Sure. Good morning, Bruce Chamberlain, Campus Energy Manager at UC Berkeley. And Berkeley is, the Energy Office is celebrated its 40-year anniversary in a couple of years ago, starting in 1978. So really proud of that history. And the Energy Office is housed in the Facility Services Department. And so it's geared towards buildings and operations. And personally, after 25 years or so in the energy efficiency industry, I was able to join the UCB team about 3 years ago and carry the torch for continued efficiency and carbon reduction. Throughout the time, the 40 years or so, we've seen the office and the efforts go from officially called the Energy Conservation Office, and it was focused on conservation, like not using energy, to efficiency over time, obviously, not a set milestone, but over time evolved into the efficiency was the key word, especially in California. And then now we're definitely in the carbon reduction mode and emphasis with a focus on electrification. So along the way, personally, I'm still adapting and always learning, which is the key, right? To understanding that energy efficiency isn't equivalent, or it's not the same as carbon reduction. And so we need to acknowledge, and that's part of the campus work, is we will probably most definitely increase kilowatt hours in order to reduce the carbon. And we can get into that later. The funding has ebbed and flowed over the years, as you can imagine. 2008, big pitch downward because of the crisis. 2017, we came up again because we purchased the cogen plant, had some funds, and now with everybody else, a complete collapse of budget. So we're scrambling in many ways in that respect. There's not a revolving fund, which I think would help flatten out those ebbs and flows. So that's another issue. And we have an Office of Sustainability on campus, which is in the Vice Chancellor's Administration Office. And that is more of an aspirational view. And someone yesterday, I'm sorry, I can't remember who to attribute it to, but someone mentioned where there's a will, we will find a way, as an example of phrase. And that's kind of, for me, there's the will aspect. In the Energy Office, which is in Facility Services, we are focused a little bit more on where there's a way, kind of the practical, what can be viably accomplished. And where there's a way, we will build the will. We focus on tracking, monitoring, and managing energy usage campus-wide. And the idea focuses just improving design, performance, and operation of buildings, reducing energy costs, and increasing awareness of energy use and water usage. We think if we can kind of attack those and address those, carbon reduction will come along with it. And I'll leave that to the others to introduce themselves.
All right, thank you, Bruce. Fahmida, would you like to go next and talk about your position and how it's tied to energy efficiency on campus?
Sure. So I direct the sustainability programs at Stanford University. Our Office of Sustainability, which I started, is squarely positioned inside our operations and facilities. So we do all our sustainability and infrastructure work together. In terms of we look at energy in three key ways. There's of course the energy efficiency in our existing building program, and that anywhere from retrofits to major retrofits, minor retrofits, building operations controls, and making sure that the demand side of the energy is as efficient as possible. We also look at the energy component in the new construction program because there is a steady pace of growth on our campus, and looking at making sure that any new construction or major renovation is as energy efficient as possible. Of course, we have Title 24, which keeps us even, but we try to exceed Title 24. And it's ever increasing stringency, which is a good thing. And of course, compared to other efficiency measures out there, LEED, Labs 21, EPA's Synergy, and more recently, well buildings component, so to speak. And then there's the actual energy supply, which is the lion's share of the carbon story. And there we've had a major transformation. Many of you may know on our campus about 5 years ago, where we retired out of our cogeneration and went towards a district level heat recovery system, which is run on electricity. So we completed our electrification path. And as a result of all of that, with our increased both energy efficiency as well as the carbon reduction, we're on path to be 80% below our peak levels in a year or so. So that's our major carbon reduction, and it happened because of electrification. Otherwise, it would have been very difficult for us to get to it if we stayed with our cogen system. And the remaining 20% of our carbon, that's also laid out through some groundwater heat exchange work, making sure all our fleet are electric, and the real hard part in this coming decade, which is to finish electrification at the building appliance level. So that's the work that we're marching towards, and that will hopefully complete our full electrification story. And of course, I'd be remiss if I didn't mention that major part of the electrification is of course fueled by the renewables component. We have California's renewable energy portfolio standard, which helps, but for all the remaining pieces, we are actually building our own solar generation station. There's 167 megawatt that's already in place in Kern County, California. And today Stanford's renewable portfolio is about 69 to 70%. And then the second solar generation station, which will finish construction in 2021, that's what's going to bring our renewable energy portfolio fully to 100%. So just kind of wanted to put that footnote that putting that all together is what's reducing our carbon to 80% below the peak that I mentioned. So electrification has been our big charter in the past decade of 2010 and 2020 that we are kind of wrapping up, and we'll continue on that path. And we're actually starting to look at scope 3 emissions as well. Some of it had to be for reporting purposes on emissions and commute and others, but starting to look seriously into purchased goods, our overall supply chain footprint, and looking at all the 15 many categories of scope 3. So maybe that'll come up in Q&A. So just to kind of wrap things up, we look at energy in 3 key buckets. Supply side and greening has been the huge initiative of this decade. And then coming up next, our scope 3 and continued work on energy efficiency and resilience, because climate change is here. And we do have to revisit, in many cases, some of our master planning and others to make sure that all the good work that we have done so far, how can we make sure that that can continue in the face of fastly evolving and changing climate? So we'll love to talk about that more in the Q&A. Thank you for having me.
Great, thank you, Fahmida. How about Joshua from UC Davis? How has energy efficiency been incorporated into your university?
Yeah, great. So Yeah, my team is the energy and engineering team in facilities, and we're really focused on efficiency in existing buildings. In fact, I have an energy engineering team that's actually funded out of the savings that they can achieve through energy efficiency projects. So it's definitely a big commitment of ours and a big opportunity. But in terms of where efficiency fits into our overall approach as a campus, we're part, as Bruce is, we're part of the UC system with a goal of carbon neutrality by 2025. And as an overall approach, our campus really does take a look at efficiency first. I think that generally is the smart thing to do. Is how can you improve your efficiency? Where are the opportunities to reduce energy usage? And that's kind of the first step toward carbon neutrality. And that's been our focus largely over the last, I would say, 15 years. We still have a lot of opportunity on that front, but we're working on it. And the next step, I think, is, as Fahmida talked about, is electrification. And we're going down the same path that they are as a district heating system. We're converting our steam system to hot water, not only for the improvement in efficiency because of the lower temperatures and less losses through the distribution system, but also because there's a huge opportunity there for heat recovery with our district cooling system. And so having that district heating system at a temperature that we can actually use the heat rejected from our cooling system is going to be a huge opportunity for us. So we're in the middle of that. Just started the first district on campus conversion at the beginning of this year. And it's going to be a probably 5 to 7 year project to convert the whole campus. But the next step is to put in the heat recovery chillers, which opens up the door to then using a lot of different low grade heat sources beyond just heat recovered from the buildings. So that's a big part of our approach to carbon neutrality is along with building efficiency, then that electrification of our heating system, which also has efficiency gains. And then the other piece of it, which ties into efficiency, and I think we've kind of taken a unique approach on, has been the engagement with the campus community, because I think that's really critical in terms of getting to carbon neutrality and efficiency in buildings. Is you got to remember what the buildings are there for. And so one of our main focuses has been to look at are the buildings doing their job? And we have an app we've developed in-house to engage students and campus community in the process. It's called Thermostat, because we have a cow theme on campus, being an ag campus. And so it gives students a chance to give feedback on the temperatures in their spaces. And so not only do we get a lot of great feedback that we didn't get before, but we also learn about the buildings in a way we didn't before. And we also are able to find those problem heating and cooling spots, as well as educate people on, we've developed a whole nother website actually just to educate how buildings heat and cool, because we found that that's a lot of the challenge is people not understanding how these systems work. And so been a big opportunity also for education and engagement, which is what we're here for as a university. So that's what I'd say our approach has been: efficiency, electrification, and engagement, if I really sum it up into 3 steps.
Great, thank you. And last but not least, Stephen Porder from Brown University. How has energy efficiency been a part of your on-campus carbon reduction goals?
Yeah, thanks for inviting someone who's not from California, just to spice it up a little bit. We have a thing in the East Coast called winter that makes it substantially more challenging than some other more friendly climes.
Thanks. Mountains do that to us too.
Yeah, I know. I know. And I, as a Stanford grad, I did appreciate that there was still winter in the mountains, even when it wasn't down there in Palo Alto. So, we're on a very similar path to the ones that have been described before. And I think we're really at a point, let me just say, to introduce myself briefly, I sit on the faculty side of things. So I'm a professor in biology, and I'm the assistant provost for sustainability. And so my expertise is more in the will side than in the way side. So I'm not I'm not an engineer, and I've learned a lot about heat recovery chillers and things like that, and district heating and cooling since I took this job. We are in the middle of a big transition in the way we think about energy efficiency. I think, like many universities, for the last say from 2000 to 2015 or so, facilities had, and the Office of Sustainability within facilities had a mandate to increase efficiency, to maximize rebates, and to try to sort of pay for itself. And there was a question of, can we pay back? If we change light bulbs, will it pay back? If we do this, will it pay back? And so there was the drive to efficiency was in the early days mitigated by payback and rebates from the utility, not mitigated, incentivized by payback and rebates from the utilities. Over time, of course, as the climate challenge has become more and more pressing, we have really started to think about paths to zero carbon emissions as the goal, as opposed to efficiency alone. And as a result, as with everybody else, we're about to rapidly increase our electric use as we drive down and eliminate fossil fuel combustion from campus. So we're in the throes of electrification. And we're also at the place where we've done a lot on efficiency that was low-hanging fruit. And the next level of efficiency, for example, renovations to buildings that are built in the 1770s are really, really expensive. And so it's not an intuitive choice. It's not always the case that making the building more efficient is the fastest path to net zero. For some of our buildings, basically we have to get them good enough to receive renewably generated heat pump driven heat. And not try to make them super efficient. It's just not possible with the old housing stock that we have. So we are sort of shifting and actually actively discussing, and I would love feedback from the other panelists about how to think about a dollar spent on efficiency versus movement towards things that will promote decarbonization. So this is an active conversation on campus. And for some things it's obvious, reducing load here and there, but really, we will soon be at 100% renewable electricity, and the next step will be to double our electricity consumption so that we can heat our buildings with renewably generated low temperature hot water. And the question then becomes, do we spend, how do we spend that money on efficiency versus the changeover of the system? And so we're actively exploring that, with engineering consultants, with our own engineers. Again, I'm not an engineer, so you all know probably much more than I, but we are at sort of a break point in how we're thinking about this, because because of our focus on carbon as opposed to just efficiency and lowering utility bills and getting rebates. So that's sort of where we stand. If Jessica Berry, who's the head of Office of Facilities Sustainability Office and Facilities Management, is on the line, she can definitely answer more about other efficiency programs on campus. But from a sort of larger conceptual framework, I would say that's sort of where we're sitting right now.
All right, great. And so a theme that's come up over a few of your comments, what Stephen Porder just said, and I know Bruce alluded to this right away, is there's a balance between energy efficiency tends to be, let's use the same amount of, let's use fewer kilowatt hours to do the same amount of service, versus carbon reductions are, well, how many megatons of CO2 can we avoid emitting? And the two aren't always aligned. So based on that theme, Bruce, do you want to get back to your topic about why you believe if the goal is carbon neutrality, why those kilowatt hours might indeed end up increasing?
Oh, yeah, certainly. And I think Josh and Stephen Stephen alluded to it by focusing on the new supply system will be electrification, and the two. If there was the phrase from someone in a movie that said, I have one word for you. If someone graduating from college, I don't know, I'm too old. People will be too young to know the movie, but I have one word for you. Instead of plastic, it'll be heat pumps. The future is heat pumps. And so because of that, the load is going, I mean, that's just the straight line increase in kilowatt hours. With heat pumps, you're electrifying buildings instead of, we have a steam loop in our campus that we're going to be reducing significantly. So therefore the carbon goes down, but the kilowatt hours will go up. I mean, there's a whole sorts of ripple effect to that. You have to look at the utility grid, the feed that comes in. But the key is, in my opinion, we have 150-year-old buildings, to get those buildings as operationally efficient as possible, taking into account Stephen's comment about, not the best energy use index, EUI, but bring it into a much improved performance level. And then the supply you can size the supply to fit a more efficient system, rather than just placing a new high-end supply system on an inefficient grid. Go ahead.
Jen, can I piggyback on that, or do you want to go around the?
Absolutely. Go ahead.
So I guess maybe to articulate it better, the shift in our thinking on efficiency has gone from a building level to a campus level. And there are some times when you don't go to the nth degree on a building because you want to save money to do the whole campus, right? And so it's for us with our scope 1 emissions coming mostly from a central heating facility, our focus is on getting the buildings efficient enough that they can be heated with low temperature hot water from that facility, and then that can be generated from renewable electricity, not making each building as efficient as it could be at an extra cost that then slows us down on switching the heat pump over. So switching the heating facility over. So it's moving from a building to a campus perspective on efficiency, I think, in a real way.
Yeah, to deal with your campus district systems. Yeah. All right. Did Josh or Fahmida want to comment on any of this?
I would jump in just to say, I totally agree, Stephen. Campuses are places where funds are limited and there's a lot of competition for them, especially when you have an old campus and a lot of buildings that need to get fixed. So our approach has shifted as well, where I mentioned the energy efficiency team in my office. What they do is really low cost measures and there's a lot of those that can be done, just basic stuff, even, improving scheduling of buildings. So, we're not running buildings when they don't need to run or turning them down. And we're recommissioning buildings. So really all we're paying for them is their salaries, and not a lot of project funding, because we don't have that. But they pay for themselves with just those things they can find. And then the larger, we've got, there's over 1,000 buildings on campus, and there's probably 100 of them I could spend at least $1 million fixing their mechanical systems, but I don't have $100 million to go spend. So what we do is, for those larger retrofits, we're trying to plan and align our planning so that they can get incorporated into larger projects when those happen in buildings. But in the meantime, let's not waste energy with the low cost stuff. And I totally agree. Focus on the central systems when you have the district system, because the bang for your buck is a lot more there, for sure.
All right. Related to this decision making of how deep you make these energy efficiency gains, when you make the decision to move forward with these capital improvements, these energy efficiency improvements, what's the expected ROI on the improvements? Is this a major metric in your decision making?
I can go on this one, especially since I didn't answer the last question. It really depends on the size of the program, but when it comes to anything related to energy efficiency, ROI is always there. It just comes in different names. In some cases, it's return on investment. Other times, it's net present value. Other times, are your rates changing or not? So I think we should take that as baseline, that yes, it is and it should be. Because this is one area of work with energy as a commodity. It actually really shows up in the equation, and it helps make a business case for those funding purposes. So it's a broad answer to the general question, is that yes, it is a factor. And depending on the type of project, different kind of ROIs can be calculated. So it can be, if it's at a building level, then it's better to do a life cycle cost type of assessment. If it's at a district level, say heat recovery or district level heat recovery, then do a full net present value. So you can really show over time the trade-offs and the optionality. You know, what are the trade-offs between say a cogeneration versus district level heat recovery. And that for that, you have to do net present value because you have to bring everything down to apples to show the different scenarios and how over time that can change. So yes, ROI is there, and how it's done depends on the size and the magnitude and the duration of the project.
All right, thanks. Stephen, did you want to comment?
Well, it's interesting, I think, because I spend a lot of time arguing that. So I completely agree with Fahmida that ROI comes into play quite in any number of ways. But I think one of the things that we need to push on our university administrations is the idea that even if this doesn't pay back in dollars, this has to be done. Right? We have as a society and as wealthy universities in a wealthy country, we have polluted the atmosphere for centuries for free. And the idea that we could very rapidly transition our systems to a different energy source without it costing money is silly. We pay for lots of things that we believe in. We pay for financial aid. We pay for all sorts of things that make our university a more hospitable place and a better learning environment. And those investments are part of what we do. And this is no different. So I agree that ROI is important, but I also think it's incumbent upon the leadership of our universities to understand that we've gotten off scot-free for a long time on fossil energy and put the burden on the world's poorest, frankly, as well as everybody else. And that's not an acceptable way of doing business. So I like that ROI is in there, but I don't want to, it's cheaper to keep burning fossil fuels right now. So if you're only looking at this quarter, it's cheaper, but that's not the way long-term institutions that are supposed to be thought leaders should be behaving, in my opinion.
Well, I guess the one thing I'll not argue on that, but just add to it is when you're making a decision on an energy efficiency gain versus a conversion to a different district heating system or something of that nature, at what point do you decide to improve the building skin versus let's just go in and change our scope 1 emission generation source? Because both of them have big dollar signs, right? And at what point do you switch from one option to another? But I understand the two are not independent. They are very much dependent on one another. But how does that?
I would, I support that too. I agree with Steve. You report on both. You report on both. The question was about ROI, so we're going there, but you're absolutely right. In making the final business case for any project, you should report on both the tangibles and as well as the intangibles. And if you can monetize the intangibles, that's even better because it helps to have a line item in the business book in order to approve a project so it can actually get done. So the virtue is to actually do both. I agree. It's just that the second one is sometimes difficult to quantify, to put a value on, say, the university brand or the reputation. But more and more, it's the co-reporting of both that's really helping all projects go through. So I agree with that general observation.
Yeah, I think there's a little bit of dissonance too between what we all think is the right thing to do and then actually funding a project, right? So like for our hot water conversion project, we presented the different options to the campus, stay as we are with steam, which is the least capital investment maybe today, but in the next 10 years, it was going to be a significant capital investment compared to what we ultimately wanted to get to, this hot water system with heat recovery, maybe geo exchange and other things. there's going to be some investment, but when we looked at the lifespan of the systems, which is actually like a 60-year life cycle cost analysis, which is a really long one, but and only useful maybe in doing comparisons between the two options to some degree. It was by far the less expensive option was to go to hot water. Does that pay for the project? No, but it does make sense to go there, right? And at least the campus could see that, you know, the path we're on is actually a lot more expensive, even if it requires less cost right now. But it still is a challenge to find the funding.
Just to add, I think it's really important to have a sober conversation about that in leadership and not just find yourself cornered by aspirational goals. And then you have to meet, you know, whatever date that is. I mean, those dates are critical and important to keep feet to the fire and get everybody moving. But the economics does come into play. I mean, if you're going to offset, you can get into a whole offset discussion of buying biogas, and that will triple or quadruple your utility bill in the future. So you got to really be wise and clear-eyed about goals and meeting those things.
All right, it looks like we have a question from the Q&A that I'd like to pose to everyone in the panel. Is there any advice on where to draw the line on in-house versus ESCOs?
Well, just to chime in a few points, for Berkeley in particular, there's a strong union representation, and so take that as you will as far as getting work done. But we look internally first there, but going back to meeting our critical goals and bending the curve, we need to scale up on a lot of projects and a lot of work. So it's obvious and clear and justifiable to outsource when we can and look at other models, such as, you know, we do PPAs for solar, but some financing and another idea is energy efficiency as a software, which is a whole nother discussion. But we're trying to break the mold a bit. Financing is not, there's minimal appetite for that right now, but I'll let others answer.
I can jump in. Sorry, Jennifer, I think you were still muted. I would say that I agree. I mean, scaling up can be challenging to do in-house. Our challenge with ESCOs has been to get what you want to get out of them, because a lot of times they're based around trying to get the most savings, and that doesn't always have the best interests of the building systems or the campus in mind. And so as much as possible, we're trying the in-house route and building up the in-house team. And then we'll manage consultants to kind of expand our capabilities and software consultants as well. But yeah, I mean, that's where, as much as possible, where we can get the experience and the knowledge in-house, I think it really is better in the long run for the university.
I see another question from Brett, I believe. He asked about where are the campuses seeing the tipping point between electrifying versus deeper reductions? Electrification leads to deeper reductions. So I think it's a subset. If electrification is done, and it's, say, if you're doing it at a district level, that is a major part of the emissions reductions equation. So it's not separate from the other. If it's at a building level and just some appliance changes, then it might have to become a business case and see if that has the life cycle pans out with the rest of the equipment equation of that building. So I think it depends on the scale, but for the most part, electrification is there if it's part of the bigger plan, so to speak. But the trick is to make sure that the sources of electricity, it remains green. So if you electrify, but your power source is brown, then you might be adding to that equation. So maybe that's the pivot point, is what is the source? If the source is green, then the more you electrify, the better.
And maybe, so I completely agree with that. Maybe to add a layer to that, for us, as we look to electrify our district heating loop, the things that are worth replacing sort of at the building or near the building are things like heat exchangers and equipment that's in the basement and readily accessible. And anything that requires going into the walls of buildings and swapping out things in rooms is really, really expensive. So what we're trying to do is figure out how many buildings we can do relatively inexpensive, low touch renovations in where we're not ripping out walls in order to get the entire heating loop to be able to provide renewably generated low temperature hot water. So there are a few buildings where, we have steam radiators and we're going to have to go in room by room and change things. But we're really trying to think about it at the systems level so that we can avoid as many of those sort of deep building gutting things as we can, because those get really expensive. And then of course, if any of those buildings are scheduled to be renovated for any other reason, or, then of course we will go in and include energy efficiency at the building scale with that renovation. But we're trying to avoid ripping walls down inside just because the cost goes up. At that point, that's just a break point in the cost for us.
All right. So related question to the ESCOs, has any of your universities utilized energy performance contracts, or does the university hire internally to develop and carry out energy efficiency projects? Now, I know we heard from UC Davis that you do as much as you can in-house, but are you guys under energy performance contracts or moving towards that space?
Do you want to know from me or others? You've heard from me, I think.
Yeah.
I think I answered that as well regarding union and outsourcing needed.
Sure.
So we are looking into it, but it's an uphill battle.
Okay.
For us, we also do as much in-house as we can. And then if the scope and the scale of the project gets bigger than that, that's when contractors come in.
Sure. All right. And then generally, how does your campus community view energy efficiency improvements? Are they well received on the campus community, or is it part of your communications plan to ensure that that's understood, that these are improvements made towards carbon neutrality or energy efficiency gains?
Yeah, I mean, generally, there's a lot of support. Of course, it's well understood that energy efficiency is always the first step in the stacking order. In fact, in our campus, if a certain building says it's on our retrofit plan, but it's say 2 years from now and not this year, they ask us to bump them up on the list. So it's quite popular. I think where it gets tricky is if its project is major enough that it might cause disruption to the area or utilities work. In our case, when we went through the whole district level a heat recovery installation, there was 122 miles of piping work that needed to happen with hot water pipe installation. And that was a disruption to campus. That's when it became a communication tool for us, that we actually had to campaign internally to really help all the departments understand, why are we doing this? How is this reducing our carbon? Back to Steve's point, that's where you bring in sort of the prestige of the university. We're doing the right thing. We're in it for not just us, for others too. And that's when we really had to communicate the project plan in a way that we've never done before, because it was so pervasive and that it would pose disruption to, and the scheduling of building and the conversion of our, the buildings. It was a very, very detailed and sensitive choreography for about 1.5 years. That became a major communications project along with a construction project. But small scale, no problems, lots of support. In fact, in many cases, we get our building managers lobby to bump up their efficiency upgrades sooner than maybe what we have planned in any given decade.
So I could chime in with three areas among many. One is energy policy. We've recently revised the energy use policy for the campus itself, and it covers mostly the key area that I think applies to this is the energy office's involvement in new construction, major modification, and review of conceptual design, schematic design, and construction documents along the way so that we can help tune the projects. There's also second area of engagement is academic resources. There's a Center for Built Environment Research nonprofit that's on campus that we pull all sorts of great expertise and research from. And then engagement with the campus is through a dashboard that's a public dashboard of all the energy use, electric use meters on all the buildings, and monthly reports that go out to division leaders and stakeholders, as well as an annual report. So and we can always improve those things. There's support to reduce carbon and reduce energy use to meet the goal, but oftentimes we're not in the loop at the right time, so then we don't want to slow things down. So that's the main thing, is communication and in early.
Okay. Great. Did Stephen or Josh want to comment on that?
I would just say that I think we've been surprised at how much communication is required to make these energy efficiency projects really successful, because a lot of the project ends up being a communication project. That's at the big level, like Fahmida was saying with the district, big replacements. That's a huge effort, communications effort that's kind of campus wide. But we also, even just in like scheduling buildings, if you really want to do a good job scheduling, you've really got to talk to a lot of the people in the buildings and have a good communication pathway. And so my energy engineers spend a lot of time doing emails and getting feedback and coordinating communication with occupants and buildings, because I think the better you have that connection, the better you can do with these projects.
All right. Well, it looks like there was one additional question that maybe just got removed, but I think I can recall what it was in the Q&A. It was a question about, do you find it challenging to find the experienced HVAC energy engineers to carry out the internal energy efficiency projects on your campus, and keeping that expertise hired and on staff?
I can talk real quick. I mean, we've been really fortunate. I think we've got a great team, but it has not been easy always to find them. I think there's benefits to coming to a campus. I mean, I came from the consulting world, and I really like being in the campus environment and the opportunities that it has. But there's challenges with pay and there's limitations. But I think that more and more it's becoming a place where a lot of cutting edge stuff is done. And so I think that's a draw too for people, is if they really want to, depending on the campus, but if you want to work on some of these things, a campus could be a great place to do it, but definitely challenging.
Yeah.
And
Okay.
I would just say I'm sorry, go ahead. If we're done, we're done. I have
No, go ahead and leave your final thoughts, of course.
Well, I was just going to say that I think California is in a very different place than many other states, and particularly, I don't know where everyone is joining from, but in Rhode Island, technical knowledge on these kinds of topics is hard to come by, and tradespeople with the requisite skills are hard to come by. That's not speaking for Brown specifically, but we actually see one of our broader impacts of doing this work as helping to train local workers in sort of thinking about buildings that are fully electric, which is a concept that is, obvious in California, right? And I mean, actually in Europe at the moment, it's certainly obvious here, but it's not obvious in Rhode Island or in New England, where the winters are cold. And part of what we're trying to do is help build that capacity, because that's actually a stumbling block, not just at the university level, but at the home level and at office building level and all sorts of things. So it varies from place to place. And I think it's it's something that is an important issue that universities can make a difference on.
All right. Well, thank you to all of our panelists for coming here and sharing their expertise from their universities. It is now 12 o'clock, so we are in a break mode. And I'm also supposed to remind everyone that at 12 o'clock Pacific time, 1 o'clock Arizona time, there is a networking session, and you can find the link for that in the chat box for this webinar. So thank you again for all of your participation and advice.
Thank
Take
you.
care.